Hello everyone, welcome back to ImTechnos. In today's video, we will dive into AWS Systems Manager Run command. We will start with an introduction to Run command and its key benefits, followed by a hands-on demo, and wrap up with some best practices to help you to optimize its usage. Let's say you're managing a fleet of 100 EC2 instances hosting a critical application. Suddenly, your security team identifies a vulnerability in the system, and you need to patch all the instances immediately by installing a security update. Manually logging into each instance, applying the patch, and verifying the update would take hours. Time you don't have during a security incident. What if you could automate this task securely and simultaneously across all your EC2 instances? That's where AWS Systems Manager Run command comes in. Run command is a capability of AWS Systems Manager that allows you to execute commands on your managed nodes without needing to log in. A managed node is an EC2 instance or an on-prem server configured for AWS Systems Manager, which must have SSM agent installed and the necessary IAM permissions to enable the AWS Systems Manager to perform administrative tasks like installing softwares, running custom scripts, or restarting services. You can use Run command through the AWS Management Console, the AWS Command Line Interface, or the AWS Software Development Kits. Run command is offered at no additional cost. You only pay for the AWS resources you use while performing tasks. Now let's look at the benefits. You can perform administrative tasks on multiple instances from a single interface, simplifying management and saving time. By removing the need of SSH or RDP, you reduce security risk associated with private keys or passwords. With IAM roles, you can control who can access and manage your EC2 instances, keeping things secure. AWS Systems Manager supports both Linux and Windows instances, making it versatile across different environments. It extends beyond AWS, allowing you to manage on-prem servers or instances from other clouds, providing a unified solution. You can pass custom parameters to your commands, making them more flexible and suited to your needs. It also integrates with tools like Automation, State Manager, CloudWatch, and CloudFormation, empowering you to create powerful workflows and gain real-time monitoring capabilities. Now that we understand the benefits of AWS Systems Manager Run command, let's jump into the hands-on demo. We will be using the AWS Management Console to explore the capabilities of Run command to install HTTPD server on EC2 instances using the AWS Systems Manager documents. Remember, the EC2 instances need to be managed, meaning they should have the SSM agent running and necessary IAM permissions. What we are going to do is, first, I launch a single EC2 instance. I'll then manually install the HTTPD server by connecting to this EC2 instance using SSH protocol. We will confirm that the HTTPD server is installed successfully by accessing the Apache default page via the browser using the public IP address. Afterwards, I will launch two EC2 instances, ensuring they are managed with the SSM agent running and necessary IAM permissions. Now, instead of installing HTTP server manually, we will use AWS Systems Manager Run command to automatically install the HTTPD server on both instances simultaneously. Finally, we will confirm the HTTPD server is running via the Apache default page using the instance's public IP addresses. To get started, ensure you have an active AWS account. You will need EC2 permissions to manage instances and assign IAM roles. Additionally, make sure you have IAM permissions to create roles with Systems Manager access. Finally, confirm that you have permissions to execute commands using AWS Systems Manager Run command. So first of all, I'll manually launch an EC2 instance and install the HTTPD server by connecting to the instance. So log into AWS Management Console. We will be doing our hands-on in North Virginia region. In the search bar, type EC2 and select it to navigate to the EC2 dashboard. From the left navigation menu, select the instances and click on Launch Instances. Under Names and Tags, name the instance as Manual HTTPD's instance. Choose Amazon Linux to AMI and select T2 Micro as instance type, which is under free type. Proceed without a key pair. Under the network settings, ensure the security group allows inbound rules for SSH and HTTP. Click Launch Instance and wait for the instance to initialize. Once the instance is ready, connect to it via EC2 dashboard. So select the instance, click Connect and choose EC2 Instance Connect. Click Connect again to establish a session. Update and install the HTTPD server with the following commands. Sudo yum update will update the packages. And let me install the HTTP server by running sudo yum install HTTPD. HTTPD, not HTTP. Start the service by running sudo systemctl start HTTPD and also enable it. So sudo systemctl enable HTTPD. Now copy the public IP address, open it in a browser and verify the Apache default page. Now step 2 is automating the HTTPD installation using the AWS Systems Manager on command. To launch 2 managed instances, navigate to the IAM console to create an IAM role. In the left navigation, select roles and click on Create Role. Choose the AWS service as a trusted entity and select EC2. And click Next. Attach the policy as Amazon SSM Managed Instance Core and click Next. Name the role as SSM Managed Role. Review the settings and click on Create. Go back to the EC2 dashboard and launch 2 EC2 instances with the IAM role attached. So click on Launch Instances. Give a tag as Run Command Instance. Choose Amazon Linux to AMI. Select T2 Micro as instance type, which is under free tier, and proceed without a key pair. Under network settings, disable SSH as we are not connecting using instance connect and enable HTTP as we need to access that Apache default page from the browser. Under advanced details, select the IAM role which we just created. Set the number of instances as 2 and click Launch Instance. And wait for the instances to be initialized. Now that the instances are created, you can edit tags as required. I will mark one instance as instance 1 and other as instance 2. Now these 2 EC2 instances are managed because these instances have IAM role attached and it has an SSM agent running. So we have chosen Amazon Linux to AMI. Amazon Linux 2 instances will have SSM agent pre-installed. So we need not explicitly install it again. So let's navigate to the Systems Manager and select Run command under Node Tools. Click Run a command and search for AWS Run Shell Script. and select that document. Keep the version as default and enter the following script in the command parameters. And make sure these commands are separated with semicolons. Scroll down. Under target selection, choose instances manually and select the 2 managed instances. Scroll down completely and click Run. You can see the command ID, which is a unique identifier for the command. And then the command status, which shows the current status of the command. There are an in-progress status as of now. And under targets and output, you can see the list of instances targeted by the command. We have 2 instances showing its instance ID and its respective status. An optional CloudWatch alarm, if you associate with the command, details about it are shown here. This can help monitor the system state during or after execution. And under command description, it includes the metadata about the command, like the document name, its version, the command ID, and date requested, and any custom comment if you add when running the command. And lastly, command parameters, where it displays the parameters that were used for the command execution, timeout values, and working directory if provided. Refresh the page to confirm the status change to success, which means command completed successfully on all targeted instances. You can also select a specific target and click on View Output, where you can see the output and error, which can be copied and downloaded. Verify by copying the each instance public IP address in the browser. To confirm, the Apache default page appears. So select instance 1, copy the public IP address, and see if it displays the default Apache page. Same with the instance 2. Select the second instance, copy the public IP address, and do the same. And that's it. We successfully set up an HTTPD server manually and automated the same process for multiple instances using Systems Manager run command. Now let's do the cleanup. Terminate all 3 EC2 instances via EC2 dashboard. And delete the IAM role created for the Systems Manager. So select it, click on delete, copy the role, and confirm the deletion. Let's conclude with best practices. Use IAM roles with the least privilege by attaching only necessary permissions. Use tags for targeting instances instead of selecting by ID. Utilize pre-built SSM documents for consistency. Of course, for complex tasks, create custom SSM documents. Test run commands on non-production instances before applying them to production. Set the timeout seconds parameter to avoid long-running commands. And finally, limit unnecessary run commands on instances to optimize AWS cost. That wraps up our hands-on session for today. If you have any questions, feel free to drop them in the comments below. Thank you so much for watching, and I'll see you in the next video. Take care and happy learning.